Hello everyone, welcome to 1045 Engineering. We are here with yet another video in Grind 75, a better blind 75 coding series. Let's jump to the problem statement for today, which is binary search. It's going to be a short video. Since it's on binary search, it is quite easy, and it is one of the most frequently asked interview question. We are going to solve it in log of n time complexity, hence the binary search. Last time we had already solved valid anagram problem. We'll mark it tick. Let's start with binary search. Okay. Let's go through the problem statement quickly. Oh, I think my internet is running a little slow. Okay. Given an array of integer nums which is sorted in ascending order. So this is one of the prerequisite for any binary search, that the array has to be sorted already. If it is not first sorted and then perform the binary search. And an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O of log n runtime complexity. So let's understand this from the example. So this is our given array. As you can see, it is already sorted, -1 0 3 5 9 12. Our target element is 9. So if you go with linear search, we are going to compare, is -1 equal to 9? No. 0, no. 3, no. 5, no. 9 equal to 9? Yes. And then we are going to return the index, 0, 1, 2, 3, 4 index. But this is linear search, and that would be in O of n time complexity. What happens in binary search is we directly search with the mid element. Let's say the mid is 3. Then we check, is the target element smaller or bigger than our mid element? So target element is bigger than 3 elements. So there is no need to search on the first half of the array, because 9 cannot exist there if it exists in this array. Let's search in the second half. Again we go to the next mid. 9 exists there. Yes, 9 is the mid. We return the index. Similarly in this one, target element is 2. We search in the mid element. Is mid element 3 equal to 2? No. Is the target element smaller or bigger? It is smaller. So we are going to search in the first half. So again we calculate the mid between these two, and 0 is the mid. Is mid the target element? No. But we have already exhausted the elements between 0 and 3. That means the target element does not exist in this array. We can return -1. Right? I hope that was helpful. Now let's start with the binary search. Okay. So for starting with binary search, we need 2 pointers. One on the left side, one on the right side, right? So let's create int, let's call it high, so that it's understandable, since it's sorted, that it is for the higher values, and lower one will be for the lower values. Is equal to nums dot length -1, right? So this pointer is pointing at the last index value, which is 12. Similarly, int low is equal to 0. This will be pointing at the first 0 index value, which is -1. Okay. Now while low is less than equal to high, right? Because if we have searched this part when we were earlier considering high as 3 and low was 0, now there is no element left in the middle. If we increase the low, the while loop exists, right? Okay, first let's find out the mid element. Int mid is equal to, you can use this formula, low plus high minus low, and then divided by 2. Okay, low in this case is 0, high is 0 1 2 3 4 5. So 5 minus 0 is 5. 5 divided by 2, it will be 2. So 0 1 2, this will be our mid element. Okay, let's go forward. We'll directly check if nums of mid is equal to the target element. So if the target element is found in the middle, we can simply return the index, which is return mid, right? Else if, now we are going to search whether this target element is smaller or bigger than our middle element. So we'll check if nums of mid is greater than target, right? So if this value is greater than target value, we'll search in the lower half. If it is smaller, we'll search in the upper half. Okay, so if it exists in the lower half, so mid is bigger than the target, that means the value can only exist in the lower half. We are going to say high is equal to mid minus 1, right? So when we are at 3, if the target element exists in our first half, we'll make this 0 as our high, and our low is already at the minus 1. Similarly, if it exists in our upper half, we'll make this as the low and the high would remain at 12. So else, which means the mid element is lower than the target, we are going to say low is equal to mid plus 1. Simple, right? And then if it is not found in this loop at all and the loop exists, that means the element doesn't exist, we are going to return minus 1. Very simple, right? Let's run it. Okay, and submit. This is log of n, so it should be giving us good results. Okay, beats 100% of the users. Maybe some of the users must have used the linear approach, but it's a binary search. You're ought to use the binary search only. Okay. Hello. So we have completed this question. Let's mark it done. That's all from today's video. Thank you, everyone. Please like, share, and subscribe. For any questions or a better approach or any comments, please let me know in the comment section. Thank you, everyone.